Consider the function f of x equals x plus 2 over x minus 6. We have a bunch of questions here we want to answer. Let's start with part A. Part A says, is the ordered pair 3, 14 on the graph of f? Alright, so we're going to start with this one. Part A. Now for an ordered pair, the first number there, that's the x value, and then 14 is going to be the y value. So if this point is on the graph of f, then it needs to satisfy this. Now the f of x is the same thing as y, so what we're going to do is we're going to plug 3 into the x and see if the function gives us 14. Alright, so we're going to plug in 3 into the function. So we're just going to replace these x's right here with 3's. So we have 3 plus 2 over 3 minus 6. Let's simplify this. 3 plus 2 is 5. 3 minus 6 is negative 3. So this is coming out to negative 5/3. We did not get 14. That means that 314 there is not on the graph. But we did find a point that is on the graph, 3, negative 5/3. So 3, negative 5/3 is on the graph. All right, so the answer to part A is going to be no. Let's move on to part B. B says, if x is 4, what is f of x? Well, this is just plugging 4 into the function. Just like we did in part A. We plugged in 3, this time we're plugging in 4. Let's see what we get when we plug in 4. Alright, so in the numerator we have 4 plus 2, that's 6. And then in the denominator, 4 minus 6 is negative 2. 6 divided by negative 2 is negative 3. So the answer to part B is going to be negative 3. Alright, let's look at part C. It says if f of x is 2, what is x? So this time it's giving you the f of x value or the y value. So with this one, I'm going to replace the left-hand side here, the f of x part, with 2. And that's going to equal x plus 2 over x minus 6. Alright, so now it wants x, so we're going to have to solve this for x. Now what I'm going to do here is I'm going to get rid of this denominator by multiplying both sides by x minus 6. That way they cancel on the right. So on the right hand side I'm just left with x plus 2. On the left I'm going to distribute the 2, so I have 2x minus 12. And we'll solve this for x. Let's subtract x on both sides and add 12 on both sides. That'll get rid of the 12's on the left and the x's on the right. 2x minus x is x. And then on the right hand side, 2 plus 12 is 14. So there you go. When f of x is 2, I'm getting an x value of 14. Let's look at part D. D says, what's the domain of f? Now with this one, we have a rational function. We have a denominator. And we cannot divide by 0 in mathematics, so the domain is going to be everything except for the x value that makes the bottom there 0. And this x minus 6 cannot be 0. If you add 6 on both sides here, we see that x is not allowed to be 6. We can't plug 6 in here on the bottom. If we plug 6 on 6 minus 6 is 0. We can't divide by 0. So the domain here is going to be all x. We can use set notation to write this. The domain is all values x such that x cannot be 6. It can be anything else, but it can't be 6. This is going to be the domain of the function. For part E, It wants us to list the x-intercept. The x-intercept is when the y value is 0. On the x-axis, the y is 0. The y values are the same as the function values. So to find the x-intercept, I'm going to replace f of x with 0. So I have 0 equals x plus 2 over x minus 6. And I just solved this for x, and that will give me the x-intercept. I'm going to do the same thing as I did in part C. I'm going to multiply both sides by x minus 6. X minus 6 cancels on the right, so I'm just left with x plus 2 on the right. On the left, 0 times anything is 0, so this is 0. And then you subtract 2 on both sides, and you get an x value of negative 2. So the x-intercept is crossing the x-axis at negative 2. If you want to write it as an ordered pair, you could write it as negative 2, comma 0. Because the x is negative 2 and the y value is 0. That is the x-intercept. We made it to the last part, part F. F wants the y-intercept. The y-intercept is going to be where this graph crosses the y-axis. The y-axis is the vertical axis. On the vertical axis, the y-axis, the x is 0. So to find the y-intercept, I'm just going to plug in 0 for x and see what I get. So I'm going to replace these x's with zeros. So we have 0 plus 2 up top and 0 minus 6 on the bottom. That's 2 divided by negative 6, and that can reduce to negative 1/3. So it's crossing the y-axis at negative 1/3. If you want to write this as an ordered pair, the x is going to be 0, and the y value will be negative 1/3. There you go.